Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. Hi everyone. Today we have with us Tiffany Harte, who is a senior research associate at the Department of Physics at the University of Cambridge in England. Hi Tiffany, how are you?
Hi, thank you so much for having me. I am very well.
Excellent. Let's dive right in. So please explain your research to us in super simple words, please.
Okay, so my lab is literally the coolest place in the universe. And that is because, yep, not just a completely out there claim, because I work with ultra cold atoms. So that means that we cool atoms down until they're less than a millionth of a degree above absolute zero. And then we use them to study complex physics in other fields. So one example of this is called quantum simulation. And this is where we trap atoms in patterns of laser light and use them to build a completely quantum, completely experimental simulation of some complicated materials, so that we can probe effects that are either difficult to calculate or directly measure in the real materials. But there are so many more applications of cold atoms as well. And in fact, my new experiment that I've been working on since May of this year will be using clouds of ultra cold atoms and the quantum interference effects between them to create a detector for dark matter and gravitational waves.
That is so cool. Literally, I just got it. Oh my God. Oh yeah, that sounds super duper cool. A very maybe silly question because I don't understand a lot about this topic, this part of material science. Which atoms do you cool down? Are there like specific elements or do you
Yeah.
just like go in the park and pick up some atoms, bring them back, and like how does that work?
No, that's such a great question. We do tend to work with specific groups of atoms. So typically the atoms that are easiest to work with are the alkali atoms. And of that, particularly rubidium is just the absolute easiest element to work with. Firstly, you've only got this one outer electron, so that makes everything a lot simpler. And it just so happens that rubidium has really nice like scattering and collision properties, which makes it very easy to cool. However, the downside of rubidium is that it's not quite so interesting or not quite so tunable as some other slightly more complicated atoms. So potassium is very often used so that you can get really nice control and tunability over interactions, for instance. And actually my new experiment will be using strontium. So that's very exciting. We've got two outer electrons to worry about now. And yeah, that's as complicated as I like my atoms to get. But strontium is really great because it's got a very, very narrow atomic transition, which means it's called a clock transition. And it means that you can make very, very precise measurements for timing using that transition. So strontium is very commonly used in atomic clocks, and it's kind of some of that same technology is going into our application with strontium for very precise timing measurements.
Wow. I thought it was a silly question, but
absolutely
you
not.
answered it really well, so I understand a bit more now. That's really amazing. So what can the followers expect in the week that you will be taking over the account, other than the cool science? Sorry, I have to make that joke. I have to like constantly make that cool science joke.
Oh, that is my one science joke, and I use it all the time. So yeah, over the week, I hope that people will get to know both me and my research. So I'm going to start off on the Monday giving just a general background to the ultra cold atom field, because there are so many applications that I haven't mentioned and that even in that week, I probably won't have time to get around to explaining. So just give people an idea of what they can be used for and how we call them, introduce myself and my job as a researcher. Then Tuesday and Wednesday be a little bit more specific. So first of all, talk about cold atoms for these quantum simulation experiments where we build these experimental simulations of real materials. And I've got some really nice experiment pictures to show that I'm very excited about. Wednesday, talking about cold atoms as detectors and talking about how we're building a brand new experiment in a way that's very unusual for atomic physics groups. It's a lot more collaborative than we're used to being. Thursday, I'm going to make it all about myself, talk about how I got into the field, like what essentially a day in my life is like, and what I do outside of my research. And then Friday is in the UK, it's the UK Quantum Technology Showcase. I actually haven't decided where I'm personally going myself because I'm a bit worried about COVID security. So I'm just going to wait and see if there are any updates to the COVID safety rules, but thought it would be a great opportunity to discuss quantum technologies and their applications a little bit more generally.
Absolutely. Yeah. That's an action-packed week. This is like, oh my God, there is so much content coming our way. And even if you don't manage to cover everything you want to talk about next week, we will be more than happy to have you in the future as well, taking over the account.
That would be wonderful. Thank you.
Excellent. So this has been lovely. Tiffany, thank you very much for speaking with us and looking forward to having you on Real Scientist Nano.
Thank you. I can't wait.
Thank you for listening. To know more about us, please visit our website realscientistsnano.org and follow us on Twitter at realsci_nano.